All right, so today we have my friend David Hughes. He is Principal Data and AI Solution Architect at Enterprise Knowledge. And the company's tagline is Achieve Enterprise Knowledge for your organization with a semantic layer. Although for this podcast, we won't be talking much about what he's doing at Enterprise Knowledge per se. We'll talk about things that David and I have mutual interest in. And if you want to follow what David is up to, you can go to his website, which is at hyperdimensionalcomputing.ai. So, David, welcome to the podcast.
Thank you, Ben, for inviting me. It's a pleasure to be here.
So, you are, I know you as an enthusiastic user of BAML. And for our listeners, the best way to find BAML is to Google boundary and then BAML, BAML. So I know you as an enthusiastic user of BAML. So what was your aha moment with this particular technology? And I guess what were the pain points that made you seek out a solution like this?
That's a great question, Ben. I have been a user of, the common frameworks that I think anyone listening to this podcast can think of. I've tried them all. And while I was able to achieve what I think are novel and innovative solutions using those frameworks, they were always brittle. And anytime some of my incoming inputs or data changed, or if I had a new model that came out and I wanted to test it, it meant a significant amount of refactoring and re-engineering, and often a lot of just prompt engineering that just never seemed rigorous programmatically to me anyway. Um, so my aha moment, this is a funny one. I was actually on a morning run in the dark woods with a headlamp listening to your podcast, and you interviewed the CEO of Boundary ML, which is who makes BAML, and you were talking to Vaibhav, and he was talking about how prompts actually are functions, in that BAML allows you to treat prompts as functions and rigorously think about your interaction with a language model and an agentic system completely and comprehensively. And I went back that night or that afternoon, blocked out my calendar and tested BAML. And I think by the time I was done that same day, I realized I wasn't going to touch another framework again.
So as you said, right? So BAML treats prompts as structured functions with defined inputs and outputs. So how has this shift from this kind of more traditional string-based prompts to, I guess, what we would call function-based prompts change your approach to prompt engineering and prompting? And can you give us some practical examples?
Sure. So the way that it's changed the way that I approach working with agents or language models is I don't focus on the prompt so much. I actually focus on what is in BAML a schema that you define by classes, and you can think of them of like Pydantic like classes. And I think about what do I want my language model interaction to give me back? And then how do I want that to be deterministic so my downstream systems can depend on what they're going to receive as inputs? I don't think about how I have to beg and plead and tell a language model that my job is on the line to get the output that I want. So I spend a lot more time thinking rigorously about my objective than how to get it. The other way that it's changed it is BAML exposes something called the playground, and the playground is an extension for most of the common IDEs that developers are working with these days. And right in the IDE, before I am actually trying to deploy code or test it in some Docker container, I actually can work with a prompt, my schema, or my outputs that I've defined, and test them right in the playground. So my iteration loop is just compressed significantly.
So, one of the things I tell people with BAML is, yes, it's a programming language, but I said it takes you maybe an hour to learn it because it's so small and so uh, specific, right? But
Mhm.
I guess, David, so what would you tell our listeners who I guess maybe tend to prioritize iteration speed and convenience and syntax readability and all of that. So, in other words, overall kind of developer productivity. Uh, you mentioned a few things. So, does that mean I have to learn so much that this is going to be a pain?
Well, as I said, I mean, I had come back from a run with this aha moment, and I would say maybe 2 hours of reading through the documentation and just opening up the playground after installing the extension in my VS Code and or cursor. I was already off to the races and being successful in refactoring significant code bases that I was working on. I was working on one for a client and using GraphRag, and then also a project that I ended up presenting on, and I think we'll talk about later around multimodal GraphRag. But it is a DSL, and as you said, it is a different language. But there's a lot of benefit in that because right now, I'm working with clients and on projects that are asserting or demanding that the code that I'm writing in is Rust. But yet, the majority of the people or developers out there working with language models and trying to build agentic solutions, they're using Python. It's still the lingua franca of that domain. But there's a lot of developers who are very rigorous in their approach and they want to start working with language models, but they don't want to learn Python just to get there. So in an hour or less, because BAML is polyglot or uses all of these different languages, they can be working with a deterministic system and approach to using language models. So yes, it is a barrier to entry that you have to spend an hour and look at some documentation, but at the same time, it opens up so many possibilities.
So you opened this podcast by mentioning you use a lot of the usual suspect frameworks.
Hmm.
Which I'll name some in
Okay.
case, so you may not be comfortable naming them. So let's say, I guess, LangChain, Llama Index, Haystack, and on the agentic side, you have Crew and a bunch of these other things. So where does BAML fit in? Is it a replacement, a supplement, or it's something else?
It is a replacement. I've used all the ones that you just mentioned, and I'll even throw in one more, LangGraph, because I do a lot of agentic work. Um, And because it allows you to define the output and it is more focused on deterministic outputs, that sets it apart from the frameworks that you mentioned, which are more around working with the prompts itself. And that entire mindset is different than when you are focused on deterministic outputs, than the frameworks that are more about creating novel prompts for the that happens to be the language model that you're using. Because that's some of the brittleness that I mentioned that BAML addresses, is that the rapid iteration and the ability to quickly swap out things like a prompt, a language model, and frankly, even the definition of the schemas that determine what your output's going to be, they're all dynamically refactorable at runtime. And we can talk about that. But in those other frameworks, the brittleness comes down to that prompt. And given a big task, there's a lot of models out there that have an affinity or a gravity for maybe one task, but don't perform very well on others. And that is the problem with those frameworks, is that the rapid iteration for the what is meteoric what we're seeing in the new models coming out weekly, there's too much refactoring that you have to do if you're working in a prompt-based system.
And it's not even so let's say you are comfortable with prompting,
Mhm.
but as you mentioned, I don't know anyone, and I don't think it's a good idea to bet on one single LLM or foundation model provider, right? So you're constantly trying to try all the different models and making sure you architect your application so that you are not tied to a single model or single model provider. right? Because I mean, Gemini has great models now. DeepSeek has great models, right? So in other words, even if you master prompting in one of these model providers, it may not work for others, right? So which leads me to my next question, David. You know, in the early days of this LLM space, we started hearing about this new role, the prompt engineer or the prompt artist, the person who's just master at just at extracting or getting something out of an LLM. So
Whisper.
does BAML effectively remove the need for such people?
I think so, largely, because you still have to write a prompt, but it's not the wizardry of knowing the ins and outs of the affinities for a particular model. And I think that that landscape was difficult for these prompt engineers to keep up with because, as I said, each model has a task affinity, and trying to learn how to, air quote, whisper to each model was getting to be, I think, a significant challenge for these prompt engineers. The philosophy, though, I really came to appreciate in speaking with the team at Boundary about BAML is that prompt engineering also typically was overloaded. People tried to ask too much of these models to do with these complex and I think very large instruction sets. I've seen prompts, hundreds of lines or more. What BAML's philosophy is, because you have a type-safe system, break those tasks down into atomic, simplified, single units of operation and reasoning, and then take advantage of what BAML exposes by composability in bringing all of that together. So now, yes, there's great language models that are coming out, and like you mentioned, some of the large ones. I actually use, I'd say 95% of the time, then small language models that are task specific. And I find that approach that BAML really puts out there of composability and using small language models that are task aligned be much more resilient. And I think the answers I get back or the outputs I get back are better.
And so another thing that a lot of teams are starting to grapple with, of course, is cost, right? So
Mhm.
token usage uh, being one proxy for that. So does BAML help me monitor any of these things, or how does BAML help me on that side of things, David?
Sure. So BAML has a couple of ways to address cost. One is right in the playground, they've taken what most developers have to use is, they import in tick token and then they have to write a function that gives them token counts, etc. But in BAML, right in the playground, I can look at what the prompt's going to be. It's not hidden in the framework. BAML is fully transparent and it will show me my tokens. What I can do is iteratively start testing my prompts, which I'd say are very terse and concise, and I can continue to reduce them and check my outputs coming out of the model and reduce what I'm getting token count wise there. The other thing is that the way that BAML injects the context that determines what my output's going to be, it's also very compressed and concise. So you'll see a significant reduction in the tokens that you're using. And then finally, I would say that most approaches that engineers are using today is that if an output coming back isn't in the format that they want, there is reprompting. So that's another API call, that's more cost. And that is where BAML, in using its schema-aligned parser, is an advantage because no matter what the language model gets back, this schema-aligned parser is going to ensure that it gets it in the output structure that the developer wants. So there's not this reprompting and cycle of going back and forth to the API just to get what you need.
Yeah, that's interesting. So actually, as you point out, one persistent challenge with these LLMs is their tendency to output approximately correct formats, right? So have you personally seen in your work significant reduction in parsing errors and I guess leading to simplified error handling through using BAML?
Yes, because even using BAML, because it's fully transparent, I can see what the language model is giving me back. And if you're giving it 100 or 1,000 inputs to process, you can see in BAML's interface when you're using the playground that a reasonable amount of the time, or maybe I should say unreasonable amount of the time, the language models are not giving me back well-formed JSON. But I can also see that the parser of BAML is then parsing that and giving me back good, well-formed, structured JSON. And there are systems out there in some of the other language models to constrain outputs, but there's a nuance there that I don't think many developers have caught on to, is in these other constrained systems, they're always going to give you back a JSON, whether it's correctly formed or the content is correct or not. BAML, on the other hand, will give you back an error if what you've asked for isn't what you receive back from the actual language model, and that can't be parsed by the parsers in BAML. So there is this ability to test your outputs, both in the playground, but also at runtime, and that saves also getting back to iteration. I don't have to do all of this wrapper engineering to get around the fact that language models are messy and don't give you back all the time what you need. BAML gives me well-defined errors that I can check for, and I can create assertions that say, is what I'm getting back an instance of some type that I've defined? So it's that kind of rigor that has cut down those iteration cycles as well.
So you've mentioned the word testing a few times, and as you
Mhm.
know, debugging these applications that rely on foundation models is notoriously challenging. So how does BAML's focus on, I guess, rigorous prompting help developers who are building applications?
Mhm. Well, language models really weren't meant to give you structured output. They are generators of the most probabilistic next token, and that's what they're good at. Prompt engineering to try and get these language models to give you an object that you need is counterintuitive to what they are designed for. That's where BAML comes in. BAML will parse that output and put it into the structure that you've defined in your schemas. For testing, because BAML is giving you a programmatic object, I can now check and do things like, is what I received an instance of, which is a function, of some type that I've defined? And in my types, I can write assertions that say, and also at runtime, I can write assertions that say, for example, let's say I'm looking for a list of colors found in an image. I can assert that that list is at least populated by one color. So if that's not the case, then I can actually take some action. Trying to do that where I couldn't count on the fact that what I got back was a well-formed object, or that it was even a list instead of some string, or that I had to parse and put it into a list. Those are all the sort of things I don't have to think about anymore when I'm using BAML.
So you alluded to this earlier, but the cross-language
Mhm.
compatibility of BAML seems important in enterprise environments, right? So you alluded to one example that you encountered, but are there others that you've heard about? So, for example, David, as you know, I mean, enterprises, while we love the hipster languages like Go and Rust, enterprises still use Java, right?
Well, I
Uh,
think that's changing though, Ben. I've worked on two projects now
No, no, but
where
just generally, so whereas most people that we talk to probably, Python, Go, Rust, right? So, but
right.
not everyone has the luxury to work in these languages, right? So they're in companies where there's a lot of legacy kind of things. So, what what would you say to people who work in such environments and might be interested in kicking the tires on in BAML?
It's easy to do because BAML being polyglot, and the philosophy is they want BAML to be the DSL for anyone writing in any language. They're agnostic. If there isn't a language that currently BAML outputs its compiled functions for, there is an API that they expose that you can use in any language. So right now, Rust, I'm using the API. I know the team's working on making that native output, so I'll be able to take advantage of that. And so Right now, I can write in any language using the API, create some stubs for when eventually that language is natively supported, and then just port to that or switch to that when it's necessary. So legacy systems, legacy companies, that's fine. BAML can
So,
support.
so one of the hot topics this year is agents, and in fact, I'm co-chairing a conference in New York. For our listeners, May 6 to 7, go to agentconference.com. Um, set aside what we mean by the word agent, right? So I guess some level of autonomy, right? So obviously, the more autonomous it is, the more it lives up to the word agent in some ways. But what role does BAML have to play in the world of agentic AI applications, if any?
Oh, a significant role. Um, so maybe 2 weeks after I first learned about BAML, the next thing I said is I want to rewrite all of the agentic systems that I had been creating in LangGraph, and how was I going to go about doing that? I was able to create
Actually,
a
David, before you proceed, give our audience like a 1 to 3 sentence description of what LangGraph is and what is it used for?
Sure. So lane graph is a way of orchestrating via a DAG, a directed acyclic graph, a compilation of agents that are generally going to be small atomic task specific, but then organized to produce a structured final output.
And this is created by the people behind LangChain.
It is. It
Right.
is.
Okay. Proceed. Yeah.
Absolutely. So I wanted to do the same thing, but in using BAML as the primitive because I didn't want any frameworks. I didn't want to have to bring in additional packages. All I wanted was a DSL, and I was going to write the rest of the code. I wanted full control. There's a lot of complexity in some of the systems that I design, and BAML seemed at the time to be the tool for me to accomplish that objective. So I was able to create agent registries where I could create an agent, tell them what reasoning engine the system had, because BAML exposes several features for the creation of, as you said, an agent that has some understanding of its environment and can take actions and make decisions and move and coordinate with other agents potentially. So in BAML, you can dynamically change the reasoning engine, the language model that an agent is using. You can create what the prompt is and dynamically change that. And then what I find to be very, I think, useful for some of these more complex systems is that at runtime, in addition to all the testing and features that BAML exposes, I can dynamically update and change the classes for what my outputs are going to be through BAML. So that structured output, I can mutate that at runtime. If I discover and make a call to a database and see that I need to change or add a feature to, let's say, an object of type person, and now I need to add social security number as one of the values in there. I can do that at runtime and then continue to get that new updated output. So uh, those are some of the features that I think are key to designing agents. Uh, where my mind goes more these days, Ben, is thinking about agentic solutions that are self-optimizing and are able to take autonomous action. It requires the ability to do those kind of mutations. If a agent is continuously not meeting some threshold of some structured output, you can change that dynamically in BAML. If it looks like the language model that the agent is using isn't the right affinity for the task you're giving it, you can change that at runtime. And these are the features that are going to make BAML, I think, even more critical as we start thinking about autonomous systems.
As I opened the podcast, right? So I described you as an enthusiastic user of BAML, and I
Mm.
forgot to mention I'm actually an angel investor in the company behind BAML. But uh, I know you check in with the team to
Mhm.
figure out what's on their roadmap. So, uh, what in particular are there specific things that caught your attention that you are excited about, or may or may not have to do with agents, but just generally, are there any things in their roadmap that you can't wait to see?
Yes. Um, in the prompt as a function, you can already do things like iterations, if statements, and they're going to be enhancing that capability to allow developers to actually put more code right into the prompt. So the concept of wrapping your head around the fact that a prompt is a function, it's going to become even more clear. I mean, there will be a lot of logic you can embed right in the prompt. So that's to me very exciting because that's going to open up a lot of capability.
What,
The
so did they give you a timeline?
I don't know if Bob wants me giving
Yeah.
out too much detail, but I can say that it's just around the corner.
Okay, great.
Maybe that's fair to say.
Yeah.
The
Yeah, yeah.
other
So one thing, listeners, about the team behind BAML is that they are very, very rigorous and careful. I
yes,
mean, nothing ships unless it's really hardened. Yeah.
and I'll say to that. Then the team developed BAML in Rust. And generally, Rust developers, but I'd say specifically this team, they are very careful. They want to make sure that anyone contributing to their code base is following their standards so that they can assert that anyone using BAML is going to be being able to do so reliably. So yeah, I appreciate that. And so sometimes if I ask for a feature, it takes a little bit longer. Uh, I'd rather have that than to get something that works most of the time, but not all the time. Yeah.
So anything else that jumps out?
Yes, so we talked about injecting more code logic right into the prompt. I know that the team is working on more native language support for things like Rust, so I'm excited about that. And then also, I believe that they are thinking about ways to replicate some of the things I was doing to create and orchestrate DAGs or agentic systems. So we'll see where they go with that. But there's a lot that they're focused on. Plus, they have other members who are using BAML as the primitive in development that I think they may look to, or it would make sense to think about what is that bigger community doing using BAML as a primitive, and maybe BAML not having to take on everything. For example, DoNew.io is really being thoughtful about autonomous agentic systems. Kuzu is a great integration for if you want to do graph RAG. It is using BAML, or the team there are starting to think about, and they have some great examples of how to use BAML with graphs. So that community around BAML is already starting to grow, and I think that once someone is exposed to BAML, they get the idea of the power of the DSL for AI.
Yeah, yeah, yeah. Actually, the one thing that uh, when I first met the team, they were not working on BAML at all, right? So, and then at some point they started working on BAML. I have to admit, at first I didn't really get it until I tried it, and then I got it, right? So it's one of these things, listeners, that you actually, like I said, invest 1 hour, and I think you will find a lot of value in that 1 hour.
I agree. You know that if you get stuck on anything, jumping onto the Discord channel for BAML, it is generally just a short time before someone on the BAML team will respond to you. Typically, it could even be Aaron or Vaibhav directly. The community is very supportive, and as you said, then I think after just an hour, most developers are going to get it, and if they don't, hit me up. I'll walk you through it. But I do think that as the visibility of BAML increases, you're hearing about it more and more at conferences and presentations. I've talked about it at two conferences, and I have four more conferences coming up this year where I'll be presenting components of BAML. So I think that the community will continue to hear about it, and we're going to start hearing about novel ways that it's being used. It really is right now word of mouth, but I think that's going to change soon.
All right, so I want to kind of tie in another short discussion on another topic that caught my attention that you're working on. So, listeners, in the beginning, there was RAG, and then after RAG, there was graph RAG. and now we're going to talk about multimodal graph rag. So obviously, I think people are from at this point. I would say people are familiar with graph rag. So what would you can you explain, David, the core concept behind what you're calling multimodal graph rag?
Absolutely. So yeah, you're right. There was graph rag for quite some time. We've been hearing a lot about it. We've seen a lot of demonstrations from various enterprises and developers.
Yeah, and let me see if we're on the same page. So to me, I don't know if you saw I wrote a post with our mutual friend Prasant, right? So to us, graph rag is just I guess rag, and then there's some knowledge graph
Mhm.
involved in the retrieval process somewhere, but we're not sticklers for how that involvement is. Some people are quite sticklers about it, but I think that's counterproductive. I think just anything with uh, RAG and a knowledge graph to us is graph RAG. I don't know if you agree.
I agree because some people think of graph rag as using agents to create a graph. And then also you could think about the true meaning of rag being a retrieval mechanism to retrieve from a pre-created graph. To me, I think that line is a little blurry because ultimately, even if an agent is creating a graph, it's ultimately going to then follow that by doing some retrieval on it.
And now you're talking about multimodal graph rag, which I assume is beyond text only. So it's
Mhm.
graph rag, but the foundation model is multimodal. Is that a fair description?
It is. I didn't end up using the some of the big commercial models to do this because again, I tend to stick with small language models that I can use that are more task specific. Um, so yes, multimodal graph rag is the inclusion of audio and video into a graph so that it can then be used at retrieval time for primarily expanding the scope and context of what a language model has to think about, but also, as I found, to provide explainability for results. And so I'll give an example. If you have a collection of images, maybe they were part of documents or a compendium that came with documents, you're losing a lot of rich latent signal in those images that the text isn't going to capture. Even if you're collecting things like the captions from the images, you're just missing a lot. And I'll give an example. If you have a picture of a table, and that table has some bananas and a bowl, and the table's made of wood, and next to the bowl is a lamp, and to the other side of the bowl is a telephone. Uh, the caption might just say a banana on a table or some bananas on a table. And that's not sufficient to truly understand what's in that image. And so what multimodal graph rag does, as has been developed, is it will take an image and decompose that into what are the predominant colors? What are the predominant objects? Because the language models like Lava, which is what I was using, can take a image and create the bounding boxes for the objects in that image. And now using bounding boxes, I can say, is this a picture of a banana because it takes up the majority of the dimension? Or is it an image that has a banana in it because it's a smaller portion? More importantly, though, because now that I know all of the objects in the image, I can do spatial analytics and I can do things like the banana is to the right of the phone, but to the left of the lamp. And all of that can be put into a graph. And there's a lot of things you can pull out, like complexity of images, colors, contrast, patterns, etc. But all of that being in a graph, showing the spatial analytics of the objects, that what kind of colors it's using, and some of the other features, then I can ask the following. Using a vector database, I'm looking for images of bananas. I get back 5 images of bananas. But because I can now take a graph result of that using the actual IDs of the images that come back from the vector search, I can now ask, what's the best images of the 5 that were similar? And I can start getting responses from a language model that says, well, these are great, but only this one is pictures of images where the bananas are predominant. and are bright yellow in color and also have that phone in them in there to the right of the phone. So there's a lot more you can do.
And so in the traditional graph rag world, uh, I think people are kind of easy to convince that, yeah, this makes sense. But I don't have a way to build a knowledge graph, right? So, you know what I mean? So it seems like people get stuck on the knowledge graph construction. So in this multimodal graph rag world, who's going to build the graph for me?
Well, the language models are decomposing the image, or if you have audio, which is something we're working on now, it's decomposing that into the components that then need to get loaded into a graph. We created a pipeline for loading that into Kuzu because we like embedded systems, and it's just a wonderful product to work with. Uh, the loading was fairly straightforward because I can actually create a data frame and load that in bulk into Kuzu. I don't have to go to the complexity of writing an entire Pythonic or Rust-based pipeline. So it's not quite as hard as you would think if you're using systems like Kuzu that can do bulk loading.
Again, David, in the graph rag world, right? So you have the knowledge graph construction, which
Mhm.
seems like obviously uh, some people already have knowledge graphs, most people don't, and so now it seems like the name of the game is some sort of automatic knowledge graph construction, which you know the knowledge graph you get may not be perfect, but may still be helpful and help you surpass plain rag, right? So
Right.
the graph rag that you get out of the knowledge graphs. So it seems like there's two schools of thought there. One is to use foundation models to do the automatic knowledge graph construction somehow. And maybe BAML can help there, right? So,
Mhm.
and then the other one is the classic create an SDK with a bunch of, use NLP. And so where do you fall? I guess I don't want you to pick sides, but where do you think, if I were to guess, I guess I'll throw my hat in the ring. If I were to guess, David, most people will end up using some tools that rely on the foundation model just because uh, people are already using that anyway, right? So using foundation models anyway. So, but I can see the argument for the old school graph people wanting to build an SDK where they have using some NLP tools and things like that and go down that direction. But how do you think this automatic knowledge graph construction space is likely to evolve? I guess
Well, maybe I'll surprise
both of these things could evolve, but which one do you think will have more traction?
Oh, so I'll maybe surprise you if that's possible then.
Yeah.
I'll try. Um, so first of all, I come from, you can see white hair.
Yeah.
I come from using those tools in legacy type approaches or maybe traditional approaches.
Yeah.
And I surprised myself when I started and as I discovered BAML that I could use a type-based system to output out exactly what I wanted for graph loading and ingestion. So I am actually using BAML. It's not a maybe, it is. Um,
To build a knowledge graph out of a corpus of unstructured text.
from the decomposition of images. And I
Oh,
use
okay.
BAML with my Lava agent or model to create structured output, and it's deterministic. So once I have that, though, the where I think the field will be going is, and this is my crystal ball, somewhat opinionated. Where I think the field is going is going to be leaning and biased towards the agentic language model systems, and here's why. Something we haven't mentioned that really affects the quality of graph retrieval and any data engineering process, but certainly graph retrieval, is semantics. You start listening to people like Jesus Barasa, and the value of ontologies in semantics becomes extremely clear. The traditional approach that we have seen typically will skip over that. there's great companies out there, and here's a plug for enterprise knowledge, but they focus on this. But there are other companies and other teams out there that get this, but they're far and few between. With an agentic system, you can take a pre-processing step and say, of my corpus, I first need to understand this by developing an ontology. Now that I know this ontology, and of course, you might want a human in the loop to check that or another agent to validate it based on some samples. But once you have an ontology, use that to define your schema in Kuzu, use that to define the classes that your BAML is going to use, and you can do all of that at runtime. So that's one of the other features of BAML is the fact that I mentioned that it was a lot of dynamic components to it. So I think that that's where we're going to end up heading is that there are domains of knowledge out there that most of the foundation models won't know about because they've been private. But if you're building an agentic system with uh, public models and you're using something like a llama in a tightly constrained service, then you can develop the ontology and understanding of that and provide that into both your ingestion in your graph and even to the language models that you are going to then be using reasoning on.
So how far away are we from someone who has like a pile of PDF files and
Mhm.
automatically create a decent knowledge graph using BAML?
Well, I think you can do now as far as creating it. Getting it to high enough quality that it could go into production, I think really comes down to that ontology piece. BAML's already got the ability with the tooling. You can create that if you know a priori what your ontology is and you've taken the time to define that and create it. But to get that into production, I think we need better agents at understanding ontologies. And so there's teams, I'm going to probably mispronounce his name, but Lietra, I think, is an AI solution for trying to get ontologies out of unstructured text. And there's other teams working on that. But once they start integrating into that knowledge graph creation using agents based on BAML, yeah, I think we're going to get there. And I don't think we're years off.
It doesn't sound like, so once some of these tools exist, it doesn't sound like it's even a 1 hour tutorial.
And that's the thing, I'll tell you, I struggle with the fact that
Yeah.
people aren't shouting from the mountaintops right now about BAML. I think that again, as the visibility increases, it's just going to be a snowball effect of people realizing that a DSL makes a lot more sense when working with AI. And I'm doing my part to try and get that visibility out there.
And in closing, David, so you've alluded to this, right? So, and I guess in throughout this conversation, we've kind of talked about two things, right? So the BAML and then multimodal. So in closing, so what is BAML gonna still be relevant in the multimodal world? Because right now, when we started talking about BAML, we talked about it in the context of text and prompts and
Mhm.
things like that, right? So at some point, you can imagine prompting with an image, right? So here's an image or some other modality is part of your prompt. So what is do you see a future where BAML still is relevant in the multimodal world? Obviously, the team will have to add some features, but do you think it's a natural progression?
Actually, I don't see a future for that because it's already in the past.
Yeah.
I already use BAML and pass images to it now, and BAML is already tuned for being able to work in a multimodal world.
Yeah, yeah.
So,
So essentially, basically, BAML is constrained by your foundation model in many ways, right?
so yeah, even right now in multimodal graph RAG, I have functions in BAML where I pass it in one of two ways. I can either pass it a URL to the images that I want it to look at in my agent in the language model to process through BAML, or if you have the need, and I did in some use cases, you can actually just take your images and encode them in base 64. BAML takes that as an input and then uses that to pass it to a language model.
And with that, thank you, David.
It was my pleasure, Ben. Thank you so much.